March 1942. The Ministry of Aircraft Production, London. Barnes Wallis stood before a room of sceptical Air Ministry officials, rolling a marble across a water-filled tank. The 54-year-old engineer, already renowned for designing the Wellington bomber's geodetic airframe, was proposing something that sounded like science fiction. "Gentlemen, I can breach the Ruhr dams," he announced, watching the marble skip across the water's surface before sinking against the far wall of the tank, "with a bomb that bounces." The silence that followed was broken by poorly suppressed laughter. Air Vice Marshal Norman Bottomley exchanged glances with his colleagues. One officer later recalled the moment in his memoir. "We thought he'd gone mad. Bouncing bombs? It sounded like something from a Jules Verne novel, not serious military planning." What those skeptical officials didn't know, what they couldn't have imagined, was that they were witnessing the birth of one of the most audacious and successful special operations in military history. Within 15 months, Wallis's ridiculous bouncing bomb would unleash hundreds of millions of tons of water into the heart of Nazi Germany's industrial heartland, creating a flood wave that would drown factories, sever railways, and shatter German confidence in their homeland's invulnerability. The mathematics of destruction were already forming in Wallis's methodical mind. A cylindrical bomb, spinning backwards at 500 RPM, dropped from precisely 60 feet at exactly 240 miles per hour, would skip across water like a stone thrown by a child, except this stone would weigh 9,250 pounds and carry 6,600 pounds of high explosive directly to the base of a dam wall where water pressure would multiply its destructive force 1,000-fold. The transformation from laboratory curiosity to operational weapon would require overcoming institutional skepticism, solving seemingly impossible engineering problems, and training an elite squadron to fly a mission that pushed the boundaries of what aviators thought possible. This is the story of how a polite, methodical engineer convinced the Royal Air Force to trust their most expensive bombers, their best crews, and their reputation on an idea that sounded like a joke. And how the Germans stopped laughing when the Möhne Dam exploded. The problem they couldn't solve. By 1942, the Allied bombing campaign against Germany faced a brutal reality. They were losing. Despite increasingly massive raids involving hundreds of bombers, German war production continued to climb. The Ruhr Valley, Germany's industrial heart, pumped out steel, munitions, and machinery protected by the densest anti-aircraft defenses on Earth. Air Chief Marshal Arthur Bomber Harris, commanding RAF Bomber Command, faced an impossible equation. His bombers could reach the Ruhr, barely. They could drop bombs on the Ruhr, imprecisely. But they couldn't reliably destroy the infrastructure that mattered. Factories could be rebuilt, rail yards could be repaired. The German war machine seemed unstoppable. The Ruhr's true vulnerability wasn't its factories, but its water. The entire industrial complex depended on a handful of massive dams: the Möhne, the Eder, the Sorpe. These artificial lakes provided hydroelectric power for the factories, drinking water for millions, and industrial process water for steel production. More importantly, they controlled devastating amounts of water. The Möhne Reservoir alone held 140 million cubic meters, enough to flood the entire valley downstream. The problem was simple. Dams are nearly impossible to destroy from the air. The Möhne Dam's designers had anticipated aerial attack. The structure was 130 feet thick at its base, built from cyclopean masonry that could shrug off direct bomb hits. Any conventional bomb dropped from high altitude would either miss entirely — bombing accuracy in 1942 averaged over 1,000 feet from the target — or explode harmlessly against the dam's massive face. To breach it, you needed to place explosives against the dam's upstream wall, preferably underwater, where water pressure would force the explosion's energy into the structure rather than dissipating into the air. But the Germans had thought of that too. Torpedo nets extended 150 feet into the reservoir, making underwater approach impossible. Anti-aircraft guns bristled from towers on the dam itself. Barrage balloons floated overhead to prevent low-altitude attack. The dam was, by every conventional military assessment, invulnerable. Barnes Wallis didn't believe in invulnerable. The man who thought in circles. Wallis's career had been built on solving problems that others dismissed as impossible. In the 1930s, when aviation engineers insisted that large bombers needed internal structural frameworks, Wallis had invented the geodetic lattice structure, a basket weave of lightweight metal that distributed stress across the entire airframe. The Wellington bomber, built on this principle, could absorb catastrophic damage and still fly home, saving thousands of aircrew lives. Now, in 1942, he was focused on water. The inspiration had come from an unlikely source, watching his children skip stones across a pond near their home in Effingham. The physics were elegant. A flat object with forward momentum and backspin would bounce across water's surface, losing velocity with each impact until it sank. But what if you could control where it sank? Wallis's initial idea was even more ambitious than attacking dams. He'd proposed an earthquake bomb, a massive weapon that would penetrate deep underground before exploding, creating seismic shocks that could collapse tunnel systems, destroy underground factories, and crater runways beyond repair. The Air Ministry had rejected it. Too heavy, too expensive, too impractical. But the earthquake bomb research had taught Wallis something crucial about explosions. They were far more destructive underwater than in air. Water's incompressibility meant that blast pressure couldn't dissipate. It focused entirely on whatever structure surrounded it. A bomb exploding against a dam wall above water might crater the surface. The same bomb exploding 30 feet underwater, pressed against the wall by water pressure, would punch through like a fist through paper. The problem was getting the bomb to the dam wall underwater. Torpedoes wouldn't work. The Germans had seen to that with their nets. A bomb dropped from high altitude would never hit the narrow target. But a bomb that skipped across the water's surface, bounced over the torpedo nets, hit the dam wall, sank down its face, and exploded at optimal depth, that could work. If he could solve about a dozen seemingly impossible engineering problems. Building the impossible. The first challenge was shape. Wallis experimented with spheres, cylinders, and drums at the Road Research Laboratory's water tank facility in Harmonsworth. He discovered that a cylinder spinning backwards like a car tire would skip more reliably than a sphere. The backspin created a boundary layer of air that prevented the bomb from diving immediately on water contact, while the cylindrical shape provided enough surface area to bounce. But how do you make a 9,000-pound cylinder bounce? The answer was speed, altitude, and spin. Through hundreds of tests with scale models, Wallis calculated that the bomb needed to be dropped from exactly 60 feet while traveling at precisely 240 miles per hour, spinning backwards at 500 revolutions per minute. The margin for error was almost zero. Drop it from 70 feet and it would shatter on impact. Drop it at 220 miles per hour and it would dive too quickly. Stop the backspin and it would cartwheel unpredictably. The bomb itself, codenamed Upkeep, was an engineering nightmare. The cylindrical casing was constructed from 3/8-inch steel plate, strong enough to survive multiple water impacts without splitting. Inside was 6,600 pounds of Torpex, an explosive mixture 50% more powerful than TNT. The whole assembly weighed 9,250 pounds and was 5 feet long and 4 feet in diameter. Making it spin presented another problem. Wallis designed a hydraulic motor powered by the Lancaster bomber's auxiliary power system that would spin the bomb for a full 10 minutes before release, bringing it up to the required 500 RPM. The bomb bay doors were removed entirely, and the Upkeep weapon hung below the aircraft in modified cradles, spinning like a massive gyroscope as the bomber approached its target. The third impossible problem was fusing. The bomb needed to sink to exactly 30 feet before exploding, deep enough for water pressure to focus the blast, not so deep that the explosion would be cushioned by too much water. Wallis designed a hydrostatic pistol that would trigger at precisely 30 feet of depth. As a backup, a simple time delay fuse would detonate the weapon 90 seconds after release, whether it was at the correct depth or not. By February 1943, Wallis had a working weapon. Now he needed to convince the RAF to use it. The skeptics who had to believe. The presentation at the Ministry of Aircraft Production in February 1943 went better than the first one, but not by much. Group Captain Sidney Bufton, Director of Bomber Operations, studied Wallis's calculations with growing concern. "Mr. Wallis, you're asking us to fly Lancasters, our most valuable bombers, at 60 feet above water at night. That's suicidal, even without German defences." Wallis didn't flinch. "I'm asking you to fly them at precisely 60 feet, Group Captain. The difference is rather important." Air Chief Marshal Harris was even more direct. Bomber Harris had built his reputation and earned his nickname through mass area bombing. The idea of special operations using modified aircraft for precision attacks violated everything he believed about strategic bombing. "This is a waste of resources," Harris told the air staff. "One raid with 500 conventional bombers would deliver more explosive tonnage than this circus trick." But Harris had opposition at the highest level. Winston Churchill himself had been briefed on Wallis's plan and was captivated. The Prime Minister understood the propaganda value of a spectacular raid against a target the Germans thought invulnerable. More importantly, Churchill's scientific advisor, Frederick Lindemann, Lord Cherwell, had reviewed Wallis's mathematics and confirmed they were sound. The final approval came in March 1943, just 2 months before the planned raid. But approval came with conditions. Wallis would get his operation, but only if he could train crews to fly the mission successfully. If the training proved the concept unworkable, the operation would be cancelled. Wallis had won his chance. Now he needed crews crazy enough to fly at 60 feet above water in the dark while being shot at. The squadron that didn't exist. On March 21, 1943, Wing Commander Guy Gibson received unusual orders. Report to RAF Scampton and form a new squadron for special duties. He was 24 years old and had already completed 3 combat tours, over 170 missions bombing Germany. He'd survived when most hadn't. Now they wanted him to train crews for something they wouldn't describe. Gibson arrived at Scampton to find empty hangars and no aircraft. His commanding officer, Air Vice Marshal Ralph Cochrane, finally explained, "You're going to attack the German dams. The method is highly classified. You'll train your crews without knowing the target until the last possible moment. They'll need to learn to fly a Lancaster at 60 feet above water at night. Can it be done?" Gibson thought for exactly 3 seconds. "Yes, sir." The new unit was designated No. 617 Squadron, though officially it didn't exist yet. Gibson was authorized to recruit crews from across Bomber Command. Specifically, he could cherry-pick the best pilots, navigators, bomb aimers, and gunners regardless of their current assignments. Other squadron commanders howled in protest as Gibson poached their top men, but the orders came from the Air Ministry. Gibson got whoever he wanted. The men he chose were extraordinary. Flight Lieutenant John Hoppy, who'd survived being shot down over the North Sea and made it back to England in a dinghy. Pilot Officer Les Knight, an Australian known for bringing damaged bombers home when others would have bailed out. Flight Lieutenant David Maltby, whose crew had complete trust in his flying. Squadron Leader Melvin Young, Gibson's friend from training days. By April 1, Gibson had 21 crews, 147 men total, and still no one except Gibson knew what they were training for. The training was unlike anything these experienced bomber crews had encountered. Normal bomber operations happened at 15,000 to 20,000 feet, high enough to avoid most flak, using darkness and altitude for protection. Gibson's crews were learning to fly at 60 feet above water, so low that a moment's inattention meant death. Pilot Officer Dave Shannon, an Australian pilot who'd joined the operation, described the training. At 60 feet, you have no time to correct mistakes. You pull back on the stick too hard, you stall and crash. You nudge the nose down slightly, you hit the water at 240 miles per hour, and that's the end of you and your crew. The Lancaster wasn't designed for this. We were turning a heavy bomber into a low-level attack aircraft through sheer bloody-mindedness. The bigger problem was judging altitude at night over water. During the day, you could see your shadow and gauge height visually. At night over dark water, you had nothing. No horizon, no visual references, just black water below and black sky above. Wallis and Gibson solved this with brilliant simplicity. 2 spotlights mounted under the aircraft, one in the nose and one under the rear fuselage, angled so their beams converged at exactly 60 feet below the aircraft. When the 2 light pools merged into a figure 8 pattern on the water's surface, you were at the correct height. The crews practiced over the Wash, the Derwent Reservoir, and other large bodies of water across England, flying night after night at suicidal altitudes until 60 feet felt normal. They lost 2 aircraft and 14 men in training accidents, more than would die on some bombing raids to Germany. But they learned. The weapon that almost failed. While Gibson's crews trained, Wallis was discovering that scaling from laboratory models to full-sized weapons introduced complications nobody had anticipated. The first full-scale test at the RAD facility in Kent seemed promising. The prototype upkeep bomb skipped beautifully across the test range. Then it hit the retaining wall and disintegrated. The steel casing, strong enough for scale models, wasn't thick enough for the full-size weapon. Back to the drawing board. Test 2, with reinforced casings, worked perfectly, until they tried spinning it at 500 RPM. The bomb's mounting brackets fractured from the gyroscopic forces. More redesign. Test 3 succeeded at skipping and surviving impact, but the hydrostatic fuse failed. The bomb sank to the correct depth, but didn't explode. Fuse redesign. By April 1943, Wallis was conducting full-scale tests at Reculver bombing range on the Kent coast, dropping genuine upkeep weapons from a modified Lancaster. Each test cost thousands of pounds, an enormous sum when Britain was nearly bankrupt from the war effort. The breakthrough came on April 29. A modified Lancaster, flown by test pilot Captain Mutt Summers, released an upkeep weapon that skipped 7 times across the Reculver range, struck the target wall, sank, and detonated exactly 30 feet down. The resulting waterspout rose 300 feet into the air. Wallis, watching from the shore, allowed himself a small smile. It worked. Now they needed to make it work against the world's most heavily defended dams at night while being shot at. The target they couldn't discuss. It wasn't until May 15, less than 48 hours before the raid, that Gibson's crews learned what they'd been training for. The briefing room at Scampton fell completely silent as the curtain pulled back from the wall map, revealing the route into Germany and the target photographs. "Gentlemen," Gibson began, "we're going to destroy the dams in the Ruhr Valley." Flight Lieutenant David Shannon later recalled, "Half of us thought it was brilliant. The other half thought we'd all be killed. Turned out we were both right." The plan was tactically complex and operationally simple. 3 waves of aircraft would attack 3 dams. Formation 1, 9 aircraft, led by Gibson, attack the Möhne Dam, then proceed to the Eder Dam if the Möhne was breached. Formation 2, 5 aircraft, attack the Sorpy Dam, which required a different bombing approach due to its earthen construction. Formation 3, 5 aircraft, mobile reserve to attack any remaining dams or targets of opportunity. The route was carefully planned to avoid known flak concentrations. They would fly at extreme low level, not just over water, but across land as well, staying below German radar coverage. The outbound route crossed the North Sea, entered Holland near the Scheldt estuary, then followed valleys and lakes across Holland and into Germany, approaching the dams from the least defended directions. Navigation would be primarily visual, following rivers, lakes, and distinctive terrain features. At 240 miles per hour and 60 feet, there was no room for navigation errors. Miss a turn and you'd fly straight into a hill or a known flak position. The bomb aimers faced the most precise challenge, dropping the bomb at exactly the right distance from the dam. Wallis had calculated that upkeep needed to be released 425 yards from the dam wall to complete its bounces and arrive at the correct impact point. Bombing rangefinders couldn't work at low altitude, so another simple solution was devised. A wooden triangle viewfinder with two nails positioned so that when the bomber looked through it, the nails would line up with the dam's towers at exactly 425 yards. When the towers appeared between the nails, you released. 3 days of rehearsals over English reservoirs had perfected the technique. Now they'd do it over water where people were shooting at them. The night the dams broke. May 16, 1943, 21:39 hours. Gibson's Lancaster, ED-932, coded AJ, accelerated down Scampton's runway, its upkeep weapon spinning at 500 RPM beneath the fuselage. 8 more Lancasters followed at 1-minute intervals, forming up over the North Sea before turning toward Holland. Flying at 100 feet above the dark water, navigation was by moonlight and Mark 14 bomb sight. The specially trained crews could identify landmarks that were just shadows to most pilots. They crossed the Dutch coast at 2300, immediately encountering light flak. Tracer fire arced up from coastal batteries, but the Lancasters were too low and too fast. Pilot Officer Bill Astell, flying AJB, wasn't fast enough. His Lancaster hit high-tension wires strung across the IJsselmeer. The aircraft cartwheeled into the water in a ball of flame. No survivors. The first loss came before they'd even reached Germany. The remaining 8 aircraft of Formation 1 pressed on, following the planned route across moonlit Dutch countryside. German defenders below heard the roar of Merlin engines but saw nothing. The Lancasters were flying at treetop level, appearing and vanishing before flak crews could react. At 0015 on May 17, Gibson's formation climbed slightly to cross the last ridge before the Möhne Dam. Below them, the massive reservoir spread out in the moonlight, its surface like hammered silver. At the far end, the dam wall rose 130 feet above the valley floor, its twin towers clearly visible in the moonlight. Gibson could see the anti-aircraft positions on the dam towers and had no illusions about what was coming. "Here we go, chaps. Set up for your run." The attack procedure was carefully choreographed. Approach at exactly 60 feet and 240 miles per hour. Spotlights converging on the water to maintain height. Bomb aimer using the triangular sight to judge release point. Once the bomb was away, climb hard to avoid the water spout from the explosion, circle around and either attack again with another aircraft or watch the results. Gibson began his run at 0028. The defenders had been watching, but they hadn't quite believed what they were seeing. A heavy bomber approaching at absurd low altitude, lights shining down onto the reservoir. Then they understood and opened fire. Tracer fire converged on Gibson's Lancaster from multiple positions. The rear gunner, Flight Sergeant George Deering, returned fire with the tail turret's 4.303 Brownings. The front gunner sprayed the flak positions with his own guns. The Lancaster shuddered through the flak curtain, Gibson holding it steady despite every instinct screaming to take evasive action. "Spotlight on! Speed 240! Height good!" called out Flight Engineer Sergeant John Pulford. "Bomb gone!" shouted Bomb Aimer Pilot Officer Spam Spafford. The upkeep weapon dropped away, its backspin making it leap forward from the aircraft. Gibson pulled up hard, climbing away from the dam. Behind him, the weapon bounced 3 times across the reservoir. Skip, 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 struck the dam wall and sank. 90 seconds later, a massive water spout erupted from the dam's base. Gibson circled back to observe. The dam wall looked intact.
"No apparent breach," Gibson radioed to the others. "We're going again." Flight Lieutenant Hoppy Hopgood made the second run at 0032, but Hopgood's luck had run out. Flak struck his Lancaster's port wing, setting fuel tanks ablaze. Hopgood, on fire and losing control, released his bomb early. It bounced over the dam wall and exploded on the power station below in a tremendous detonation that killed everyone inside. Hopgood's burning Lancaster staggered away from the dam, climbing desperately. At 500 feet, he gave the order to bail out. 2 crew members escaped before the aircraft exploded. Hopgood and 2 others died in the wreckage. The rear gunner, Pilot Officer Tony Bircher, was blown clear by the explosion, but his parachute didn't deploy. He fell into the reservoir and somehow survived, the only man ever known to survive a fall from an exploding bomber without a parachute.
Flight Lieutenant Mick Martin made the third run. His bomb bounced perfectly, struck the dam, sank, and exploded. Still no visible breach. Squadron leader Melvin Young went fourth. Another perfect drop. Another massive explosion. The dam wall trembled, but held. Flight Lieutenant David Maltby prepared for the fifth attack. By now, the defenders were fully alert, their fire concentrated and deadly. But they were also running low on ammunition. 4 previous attacks had depleted their magazines. Maltby's run was perfect. His bomb bounced precisely 3 times, struck the dam wall dead center, and sank to optimal depth. The explosion at 0049 was different. Even before the waterspout subsided, observers saw something new, a dark line appearing in the dam wall, growing wider. Water began spurting through the crack. "I think she's going," Gibson transmitted. They watched, mesmerized, as the crack widened. Then, with a roar audible over the sound of the circling Lancaster's engines, a section of the dam wall collapsed. What began as a crack became a torrent, became a deluge. The Möhne Dam had been breached. 140 million cubic meters of water, enough to fill 56,000 Olympic swimming pools, began pouring through a gap that grew to 250 feet wide. The flood wave that thundered down the valley toward the Ruhr was 30 feet high and traveling at 15 miles per hour. Gibson circled once more, watching the reservoir drain, then transmitted, "Goner. Message from nigger." Goner was the code word for a successful Möhne breach. Nigger was Gibson's black Labrador, which had been killed by a car the day before the raid. The code word was a tribute. Gibson led his remaining aircraft toward the secondary target, the Eder Dam. The Eder, fighting geography. If the Möhne was difficult, the Eder was nearly impossible. The Eder Dam sat in a winding valley, surrounded by heavily forested hills, rising 1,000 feet above the reservoir. The approach required diving down through a gap in the hills, leveling out over the water at exactly 60 feet, dropping the bomb, then pulling up sharply to avoid crashing into the hills on the far side. Flight Lieutenant Dave Shannon made the first attempt. Diving down through the gap, he found himself too high and too fast. He pulled up without releasing, circling around for another try. Second attempt, too low, risking striking the water before releasing. Third attempt, wrong angle. He pulled away, letting someone else try. Flight Lieutenant Mick Martin tried next and encountered the same problems. The terrain made the precise altitude and speed combination nearly impossible to achieve. Shannon tried again. This time everything lined up. Altitude perfect, speed correct, bomb-aimer's triangular sight showing the towers in perfect alignment. Bomb gone. The upkeep bounced cleanly, struck the dam wall, and exploded. A massive waterspout rose, subsided, and revealed an intact dam. The explosion had damaged the wall, but not breached it. Squadron leader Henry Maudsley made the next run, but Maudsley released late. The bomb struck the parapet of the dam wall and exploded on the surface. The detonation damaged Maudsley's Lancaster, and he transmitted that he was heading home. His aircraft crashed en route. There were no survivors. Flight Lieutenant Les Knight, a 22-year-old Australian, prepared for what would be the final attack. By now it was after 01:30, and fuel was becoming critical. This was the last chance. Knight's approach was perfect. Diving through the hills, leveling out at exactly 60 feet, speed precisely 240 miles per hour, the spotlights converging in their figure-8 pattern on the dark water. His bomb-aimer, Flying Officer Edward Johnson, watched the dam towers through his triangular sight. Bomb gone. The upkeep weapon bounced 4 times. Skip, 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 struck the dam wall center mass and sank. Knight pulled up hard, climbing desperately to clear the hills. Behind him, the explosion erupted from the base of the dam, and this time the wall cracked. The breach began as a trickle, became a stream, became a flood. Within minutes, a section of the Eder Dam collapsed. Another 200 million cubic meters of water began draining down the Eder Valley toward the Weser River system. Gibson transmitted the success code, dinghy, and turned for home. Behind him, the geography of central Germany was being violently rewritten by 340 million cubic meters of water that should have been safely contained behind dam walls. The flood that changed everything. The flood waves from the Möhne and Eder dams arrived with almost no warning. At 00:50, the flood from the Möhne Dam struck the first villages downstream. A wall of water 30 feet high, travelling at 15 miles per hour, swept away everything in its path. The town of Niederense, directly below the dam, simply ceased to exist. Buildings, streets, people, all gone in minutes. The flood wave swept down the Ruhr Valley, demolishing villages, destroying bridges, and flooding factories. The power station serving the entire region went offline as water submerged the generators. Railway bridges collapsed, severing the main lines into the Ruhr industrial heartland. At the Neheim-Hüsten rail yards, 150 freight cars loaded with munitions and supplies were swept away. The flood wave struck a factory complex housing forced laborers at 01:45. Over 700 workers, most of them Russian and Ukrainian women, drowned in their locked barracks before guards could evacuate them. The flood from the Eder Dam followed the Eder and Fulda river valleys, reaching Kassel by dawn. Critical infrastructure collapsed: water supply systems, electrical distribution networks, sewage treatment plants. The Mittelland Canal, a crucial transportation artery, was breached in 3 places. By dawn on May 17th, the floodwaters had destroyed 11 factories critical to the German war economy, 25 road bridges, 21 railway bridges, 92 factories producing munitions and steel, 3 power stations, approximately 6,500 livestock killed, an estimated 1,600 human casualties, including over 700 forced laborers. The strategic impact was initially unclear. Some analysts argued the raid had been a spectacular success. Others pointed out that the dams could be repaired and production would resume. The truth was more nuanced. The material damage was severe but recoverable. Germany diverted 7,000 skilled workers from Atlantic Wall construction to repair the dams. But the psychological impact was devastating. The raid proved that no target in Germany was safe, even those protected by geography and massive defences. More importantly for the Allies, the raid was a spectacular propaganda victory at a time when victory seemed distant. The Dambusters became instant heroes, proof that British ingenuity and courage could strike back at the heart of Nazi Germany. The crews who didn't return. Of the 19 Lancasters that departed Scampton on May 16, 8 didn't return. 53 airmen died that night, including some of the most experienced bomber crews in the RAF. The casualty rate, 40% of crews lost, would have been unacceptable for a conventional bombing raid. But this was no conventional raid. The losses began over Holland, continued over the dams, and concluded on the flight home. Aircraft were shot down by flak, struck high-tension wires in the darkness, or simply vanished without explanation. Flight Lieutenant Bill Estelle, killed when his Lancaster hit power lines over the Eiselmeer. Pilot Officer Louis Burpee, shot down by flak over Tilburg on the return flight. Flight Lieutenant John Hopgood, aircraft set ablaze over the Möhne Dam, exploded shortly after his crew bailed out. Squadron leader Henry Maudsley, damaged by his own bomb at the Eder Dam, crashed near Emmerich on the return flight. Flight Lieutenant Barlow, struck high-tension wires near Halden, exploded on impact. Pilot Officer Otley, shot down by flak near Ham. Pilot Officer Byers, shot down by a night fighter near Castricum. Flight Sergeant Townsend, exact circumstances unknown, aircraft lost over Holland. 34 of the dead were between 20 and 25 years old. They'd trained for 5 weeks for a mission that lasted 1 night. None hesitated. The aftermath, victory and controversy. The immediate British reaction was jubilation. Press coverage was extensive. Within days, the Dambusters Raid was front-page news across the Allied world. Gibson received the Victoriacross, Britain's highest decoration for valour. 33 other crew members received various awards for gallantry. The propaganda value was incalculable. At a time when the war news was mostly grim, defeats in North Africa, setbacks in the Atlantic, the Dambusters proved Britain could still strike spectacular blows against Germany. Newsreel footage showed the breached dams, the flooded valleys, the destroyed factories. What the footage didn't show were the civilian casualties. Of the approximately 1,600 dead, fewer than 40 were German military personnel. The rest were civilians, including over 700 forced labourers locked in barracks when the flood hit. The ethical questions would haunt some of the survivors. Was the destruction of industrial infrastructure worth the civilian casualties? Could the flood deaths be classified as collateral damage, or were they a direct consequence of the attack? Gibson wrestled with these questions privately. In public, he maintained that the raid had been a legitimate attack on military-industrial targets. The forced labourers' deaths, he argued, were the responsibility of the Germans who'd imprisoned them in the flood zone, not the RAF crews who'd breached the dams. The strategic assessment was equally complex. Initial estimates suggested the raid had set back German war production by months. Later analysis was more pessimistic. The dams were repaired faster than expected, and German industrial output continued climbing throughout 1943. But the raid's impact went beyond tonnage of steel production. The Germans diverted thousands of workers and enormous quantities of materials to repair the dams and strengthen defences elsewhere. Resources that might have built Atlantic Wall fortifications instead went to protecting infrastructure the Germans had thought invulnerable. More significantly, the raid demonstrated the effectiveness of precision special operations versus mass area bombing. Harris's Bomber Command had been conducting 1,000-bomber raids that destroyed entire cities, but often missed critical industrial targets. The Dambusters hit exactly what they aimed at, with 19 aircraft. The tactical lessons were immediate. Elite crews, specialized weapons, intensive training, and precision attacks could achieve what mass bombing couldn't. These principles would inform future special operations throughout the war. The science that worked. Barnes Wallis's bouncing bomb succeeded because the physics were precisely correct. The weapon weighed exactly 9,250 pounds, heavy enough to deliver destructive force, but light enough for a Lancaster to carry. The cylindrical shape and backspin created predictable skipping behavior. The release altitude of 60 feet and speed of 240 miles per hour were the only combination that allowed the bomb to bounce the required 3 to 5 times without shattering or diving prematurely. The hydrostatic fuse worked perfectly, detonating at exactly 30 feet of depth, where water pressure multiplied the explosive force into the dam wall. The 6,600 pounds of Torpex explosive was precisely the amount needed to crack Cyclopean masonry under water pressure. Every variable had been calculated, tested, and verified. What looked like a circus trick was actually precision engineering applied to destructive purposes. After the war, Wallis calculated that conventional bombing would have required approximately 1,200 bomber sorties dropping 8,000 tons of bombs to inflict equivalent damage to what 19 Lancasters achieved in one night. The cost in aircraft losses, crew casualties, and bombs not dropped elsewhere would have been prohibitive. The bouncing bomb worked because Wallis understood that you don't fight dams with brute force, you fight them with physics. The squadron that became legend, No. 617 Squadron, continued operations throughout the war, conducting some of the most technically demanding missions in Bomber Command. They sank the German battleship Tirpitz using Wallis's next invention, the 12,000-pound Tallboy earthquake bomb. They destroyed the Semur railway tunnel, blocking a critical German supply route. They attacked V-2 rocket sites, U-boat pens, and hardened command bunkers. The squadron developed a reputation for taking impossible missions and making them succeed. They weren't the largest squadron, or the one that dropped the most bombs. They were the specialists, The cruise you called when precision mattered more than tonnage. Guy Gibson didn't survive to see the war's end. He was killed in September 1944 when his Mosquito crashed during a raid on Germany. He was 26 years old. His Victoria Cross and the legend of the Dambusters ensured he would never be forgotten. Barnes Wallis continued inventing until his death in 1979, at age 92. He developed swing-wing aircraft designs, supersonic concepts, and continued refining his earthquake bomb theories. But he's remembered for a cylinder that bounced across water, proof that the most elegant solutions often appear absurd until they work. The Germans who learned too late. German reaction to the raid was a mixture of shock, disbelief, and grudging admiration. Albert Speer, Reich Minister of Armaments, inspected the damage personally on May 18. His report to Hitler was sobering. The destruction is far worse than we anticipated. If the British could strike dams we considered invulnerable, what else might they attack that we've assumed was safe? The German engineering community was particularly stunned. They'd designed the dams to withstand conventional attack. They'd installed torpedo nets, anti-aircraft defenses, and early warning systems. Yet the British had bypassed every defense with a weapon that seemed to come from science fiction. Luftwaffe interrogators questioning captured RAF crew members were initially skeptical of the bouncing bomb concept. It sounded like a cover story for some other weapon. When the prisoners insisted the bombs had bounced across the water, German engineers were brought in to assess feasibility. Their conclusion: theoretically possible, but practically improbable. The precision required seemed beyond human capability. That assessment revealed the fundamental difference in military philosophy. The Germans assumed that if something was extremely difficult, it was effectively impossible. The British, or more specifically Barnes Wallis, assumed that if something was theoretically possible, engineering and training could make it practical. General Major Joseph Kamhaber, commanding German night fighter defenses, ordered an immediate review of all critical infrastructure. His report identified hundreds of targets that could theoretically be attacked using similar specialized weapons: bridges, viaducts, shipyards, underground facilities. The paranoia that followed was itself a strategic victory for the Allies. Germany diverted resources to defending targets that would never be attacked, all because one successful raid proved their defenses weren't invulnerable. The bomb that almost wasn't. Perhaps the most remarkable aspect of the Dambusters Raid was how close it came to never happening. In December 1942, just 5 months before the raid, the Air Ministry had nearly cancelled the entire project. The weapons were expensive, the training was consuming resources needed elsewhere, and many senior officers remained skeptical that bouncing bombs would work in combat conditions. Harris continued arguing that conventional mass bombing would be more effective. Other commanders wanted the Lancaster bombers and elite crews assigned to normal operations rather than wasted on experimental weapons. What saved the project was political pressure from Churchill and the growing desperation of 1942. Britain needed a dramatic success, something to prove they could still hurt Germany despite years of setbacks. The bouncing bomb offered that possibility. If the Air Ministry had cancelled the project in December, or if full-scale testing had failed in March, or if Gibson's crews had been unable to master low-altitude flight, the raid would never have happened. The Ruhr dams would have remained intact, 617 Squadron would never have formed, and Barnes Wallis might be remembered only as the man who designed the Wellington bomber. Instead, everything aligned. The weapon worked, the crews trained successfully, the weather cooperated, and on one perfect night in May 1943, the impossible became real. The attack they couldn't repeat. The Germans repaired the Möhne Dam in less than 5 months. By September 1943, the reservoir was filling again. The Eder Dam took slightly longer, but was operational by early 1944. The RAF never attempted a second Dambusters-style raid. Partly this was because the element of surprise was gone. The Germans massively reinforced dam defences with additional anti-aircraft batteries, smoke generators to obscure the reservoirs, and even chain booms stretched across the water to detonate bouncing bombs prematurely. But the deeper reason was that the upkeep weapon had been designed for one specific mission. It worked brilliantly against dams, but was useless against other targets. The Lancasters required for carrying upkeep weapons had been extensively modified, limiting their usefulness for conventional bombing. Most importantly, Wallis had already moved on to his next project, the Tall Boy and Grand Slam earthquake bombs. These weapons could penetrate hardened concrete bunkers, destroy underground facilities, and crater runways so thoroughly they couldn't be repaired. They represented the evolution of Wallis's thinking, from precision bouncing bombs to precision penetration bombs. The bouncing bomb had served its purpose. It proved the concept of specialized weapons for special targets. The fact that it was never used again didn't diminish its success. It simply meant the tactical situation that required such a weapon never recurred. The crews who carried the secret. The surviving Dambusters crews were forbidden from discussing the raid's technical details for months after the operation. The bouncing bomb concept remained classified. The British didn't want the Germans or anyone else fully understanding the weapon's principles. This created an odd situation where the raid was internationally famous, but crucial details were censored. Newspaper accounts described a new weapon and innovative tactics without explaining what those innovations actually were. Flight Lieutenant Dave Shannon, one of the pilots at the Eder Dam, recalled the frustration. Everyone wanted to know how we'd done it. Family, friends, reporters, and we couldn't tell them. We'd just smile and say it was classified. They thought we were being modest. Actually, we'd have faced court-martial for revealing the details. The full story didn't emerge until 1951, when the film The Dambusters was released. By then, the technical details were declassified, and the story could be told without compromising national security. The film cemented the raid in British popular consciousness. Paul Brickhill's book, The Dambusters, published in 1951, became an international bestseller. The mission that had been a spectacular but classified military operation became a cultural touchstone, the epitome of British ingenuity, courage, and determination. Interestingly, the film omitted the civilian casualties and forced labourer deaths. The 1950s British public wasn't ready to grapple with those moral complexities. The story was simplified. Brave British crews attacked German military-industrial targets, achieved spectacular success, paid a heavy price. The reality was messier. The engineer who never stopped. Barnes Wallis remained obsessed with improving weapons throughout the war. The bouncing bomb was just the beginning. His tallboy bomb, 12,000 pounds of streamlined destruction, could penetrate 16 feet of reinforced concrete before exploding. It sank the German battleship Tirpitz when conventional bombs had failed. It destroyed the Bielefeld viaduct that had survived hundreds of bombing raids. It created earthquake effects that collapsed tunnels and underground facilities. The Grand Slam, Wallis's ultimate earthquake bomb, weighed 22,000 pounds and could penetrate 20 feet of concrete. Only the Lancaster could carry it, and only after further modifications. Dropped from 15,000 feet, it reached supersonic speeds before impact, punching through any structure the Germans could build. These weapons validated Wallis's original concept. Precision bombs against specific targets achieved more than mass bombing of cities. A single Grand Slam could destroy what 1,000 conventional bombs couldn't touch. But Wallis himself was troubled by the destruction his weapons caused. In his later years, he became an advocate for international arms control and nuclear disarmament. The man who designed some of World War II's most destructive weapons spent his final decades arguing for peace. In a 1972 interview, Wallis was asked if he regretted inventing the bouncing bomb. His answer was nuanced. "I regret that such weapons were necessary. I don't regret that when they were necessary, they worked. The alternative to developing effective weapons in 1943 would have been losing the war. That would have meant more deaths, not fewer." The math that saved lives. One often overlooked aspect of the Dambusters Raid was how the precision of the attack actually minimized casualties compared to conventional alternatives. Harris's Bomber Command would have needed approximately 1,200 bomber sorties to inflict equivalent damage to the dams. At the typical loss rate of 5% for raids deep into Germany, that would have meant 60 bombers shot down and 420 aircrew killed or captured. The raid as executed cost 8 aircraft and 53 crew members. Terrible losses for one night, but far less than the conventional alternative would have required. Similarly, the precision attack on the dams caused approximately 1,600 civilian deaths, a horrific number. But conventional area bombing of the Ruhr Valley to achieve similar industrial disruption would have killed tens of thousands. The Hamburg firestorm raids 2 months later killed 37,000 civilians in a single night. This doesn't make the Dambusters' civilian casualties acceptable or justified, but it does illustrate that precision weapons, however spectacular and destructive, were often less deadly to civilians than mass area bombing. Wallis understood this. His earthquake bombs and bouncing bombs were designed to destroy specific industrial and military targets, not cities. They represented a more discriminating form of warfare, not humane, but more controlled than the alternative. The tragic irony is that precision bombing technology wasn't widely adopted until decades later. The Second World War remained dominated by mass area bombing that killed hundreds of thousands of civilians. The Dambusters Raid was an exception, not a precedent. The legend that outlived the men. By the 1960s, most of the surviving Dambusters had returned to civilian life. They were pilots for commercial airlines, engineers, businessmen. They'd moved on from their moment of fame. But the public hadn't moved on. The Dambusters film remained popular. School children learned about the raid. Veterans groups invited the survivors to speak. The bouncing bomb had become part of British cultural identity. Some survivors embraced the attention. Others found it uncomfortable. They'd been young men doing their duty, not heroes. The mission had been successful, but it had killed their friends. The celebration felt wrong to men who remembered pulling bodies from crashed Lancasters. Les Knight, the Australian pilot who'd breached the Eder Dam, didn't survive long enough to be celebrated. He was killed 3 months after the raid when his Lancaster was shot down over the Netherlands. He was 22 years old. Dave Shannon survived the war, returned to Australia and lived until 1993. He attended Dambusters reunions but rarely spoke about the raid in public. In a late interview he said, "We did what we were trained to do. It worked out. A lot of good men died. I don't know if it's something to celebrate, but I understand why people want to remember it." By 2025, all the Dambusters crew members are gone. The last survivor, George "Johnny" Johnson, died in 2022 at age 101. With his passing, the raid transitioned from living memory to history. But the story persists. The bouncing bomb remains iconic, proof that engineering genius, intensive training, and extraordinary courage can achieve what seems impossible. The raid that changed warfare. The Dambusters Raid's ultimate legacy wasn't the dams they breached or even the industrial damage they inflicted. It was proving that special operations with specialized weapons could achieve strategic effects that mass bombing couldn't. The Doolittle Raid on Tokyo, 1942, had shown that morale and psychological impact mattered as much as material damage. The Dambusters, 1943, proved that precision attacks on infrastructure could disrupt enemy capability more effectively than city bombing. Post-war precision weapons, from guided missiles to smart bombs, descended directly from this philosophy. Modern special operations doctrine, small units, specialized equipment, intensive training, precision strikes, echoes Guy Gibson's 617 Squadron. The engineers who designed cruise missiles and precision-guided munitions studied Wallis's work. The tacticians who planned special operations missions studied Gibson's training methods. The concept of effects-based operations, achieving strategic results through precise targeting, originated with missions like the Dambusters. None of this was obvious in May 1943. The raid seemed like a one-off spectacular, brilliant but not reproducible. Only in retrospect did it become clear that the Dambusters had demonstrated a new way of thinking about strategic warfare. The bomb that changed engineering. The technical legacy of Wallis's bouncing bomb extended far beyond military applications. The weapon required solving complex problems in material science, structural engineering, fluid dynamics, and gyroscopic physics. Many of these solutions found post-war civilian applications. The structural analysis techniques Wallis developed for ensuring the bomb's casing could survive multiple high-velocity water impacts influenced aircraft design and crash safety research. The hydrostatic fusing mechanisms pioneered for upkeep weapons informed underwater sensor technology. The precision navigation and low-altitude flying techniques developed for the raid influenced commercial aviation safety procedures. The synchronized weapons systems and fail-safe mechanisms became standard in aerospace engineering. Wallis's work on spinning projectiles and their behavior when striking surfaces at high velocity contributed to research in everything from automotive safety to sports equipment design. More broadly, the bouncing bomb demonstrated that complex engineering problems could be solved through systematic testing and iterative design. Wallis didn't build the perfect weapon on the first try. He built dozens of prototypes, tested relentlessly, analyzed failures, and refined the design until it worked. This methodical approach to engineering innovation became standard practice in post-war aerospace and defense industries. The culture of test, analyze, redesign, test again traces directly to engineers like Wallis, who proved that iterative development produced better results than trying to design perfect systems from scratch. The story that won't die. 82 years after the raid, the Dambusters remain part of British cultural consciousness. The breached dams have been rebuilt and reinforced. The Möhne and Eder reservoirs serve the same purposes today as they did in 1943: hydroelectric power, water supply, flood control. Tourists visit the dams and see memorial plaques commemorating both the raid and its victims. In Britain, 617 Squadron still exists, now flying Typhoon fighters. They maintain the Dambusters traditions and display the famous breach in the dam as their squadron badge. Modern RAF pilots know the story and understand they're maintaining a legacy that dates to one night in May 1943. The Imperial War Museum displays a remaining upkeep weapon, one of only 2 surviving examples. Visitors see the cylindrical bomb and struggle to understand how something so ungainly could have been so effective. The docents explain the physics: backspin, water impact, skip distance, optimal depth. The math that seemed absurd until it worked. RAF Scampton, where 617 Squadron trained and launched the raid, is now partially closed. But the hangars that housed the modified Lancasters still stand. Walking across the airfield, you can imagine the scene. 19 bombers, their upkeep weapons spinning beneath them, engines roaring, crews knowing that half might not return. The cemetery at Reichswald Forest contains the graves of many Dambusters who didn't come home. Their headstones are maintained by the Commonwealth War Graves Commission, visited by relatives who never knew them and historians who study their mission. In Germany, there's less celebration but quiet acknowledgement. The raid was militarily legitimate. Dams supplying industrial regions are valid targets in wartime. The civilian casualties were tragic but comparable to or less than what German bombing had inflicted on British cities. History has rendered its verdict: the raid was legal, effective, and strategically justified, even though its human cost was severe. The innovation that mattered. Looking back across 8 decades, what made the Dambusters Raid significant wasn't the dams they breached or even the industrial damage they caused. It was proving that innovation could trump overwhelming force. The Germans had every advantage: interior lines, fortified positions, experienced defenders, prepared fallback plans. They'd built dams designed to survive anything the Allies could throw at them. And they were defeated by a middle-aged engineer who watched his children skip stones across a pond and thought, what if we could make a bomb do that? That moment of insight, translated through months of calculation, testing, and refinement, produced a weapon that bypassed invulnerable defenses and struck the Germans where they were absolutely certain they were safe. The 19 Lancaster crews who executed the mission were extraordinary. Their skill, courage, and precision under fire deserves every accolade they received. But the raid's lasting significance is that it proved engineering creativity could overcome any defense. You can build the thickest walls, deploy the most guns, install every possible defense. And someone will invent a bomb that bounces over your torpedo nets and explodes precisely where you're most vulnerable. The moment the laughter stopped. May 17, 1943, 01:30 hours. The observation post at the Möhne Dam. Obergefreiter Karl Schutter, one of the anti-aircraft gunners who survived the attack, described the moment he realized what was happening. "We'd been shooting at the British bombers for half an hour. We'd hit several, seen them burn, watched them crash. We thought we were winning. Then I heard a sound I'd never heard before, a deep groaning, like the earth itself was breaking. I looked at the dam wall and saw the crack. In that moment, I understood we'd lost something we could never get back. Not just the dam, our confidence that we were safe behind our concrete and steel." That crack in the Möhne dam wall represented a crack in German psychological defense. If the Ruhr dams could be breached, what else might fall? The Atlantic Wall? The U-boat pens? Berlin itself? The British had proven that no defense was absolute, no target truly invulnerable. Engineering genius combined with courage and precision could penetrate any defense the Germans could devise. And it had all started with an idea that made people laugh. A bomb that bounces. The verdict of history. Modern military historians debate the Dambusters Raid's strategic effectiveness. Some argue it was a spectacular but ultimately limited operation. The dams were repaired, production resumed, the war continued for 2 more years. Others point to the psychological impact, the resource diversion for repairs, and the demonstration that British innovation could strike back even when conventional bombing seemed ineffective. The truth is probably both. The raid's material impact was significant but temporary. Its psychological and propaganda impact was enormous and lasting. What's indisputable is that the raid demonstrated principles that remain relevant today. Innovation beats overwhelming force. The Germans had superior defensive positions and firepower. They lost to a weapon they hadn't imagined was possible. Precision achieves what mass cannot. 19 aircraft accomplished what hundreds couldn't have done through conventional bombing. Training enables the impossible. Gibson's crews learned to fly missions that seemed suicidal and executed them with extraordinary precision. Institutional skepticism must be overcome. The bouncing bomb almost died in committee because it seemed too absurd. Wallis's persistence saved the concept. Simple solutions to complex problems. The bomb release site was a wooden triangle with 2 nails. The altitude measurement was 2 spotlights. Genius doesn't require complexity. These lessons transcend the specific historical moment. They apply to any situation where conventional approaches have failed and innovative thinking is required. The engineer's epitaph. Barnes Wallis died in 1979 at age 92. His obituary in the Times focused on his aircraft designs, the Wellington bomber, his swing-wing research, his contributions to supersonic flight. The bouncing bomb was mentioned almost as an afterthought. But Wallis knew what his legacy would be. In one of his last interviews, he said, "I've worked on dozens of projects over my career. Some were more technically sophisticated than the bouncing bomb. Some were more scientifically interesting. But the dam-busting weapon will be what I'm remembered for, and I suppose that's appropriate. It solved an impossible problem at a moment when solving impossible problems was desperately necessary." His gravestone in Effingham, Surrey, is simple: Barnes Neville Wallis, CBE, FRS, RDAS, 1887–1979, engineer. No mention of bombs or dams or warfare, just engineer. Because that's what he was. A man who looked at problems, whether building aircraft, destroying dams, or achieving supersonic flight, and worked methodically until he found solutions. The bouncing bomb was the most famous solution, but it was just one of many. Wallis's career exemplified the engineer's mindset: define the problem, understand the physics, test possible solutions, refine until it works. That mindset, more than any specific weapon, was his true legacy. They stopped laughing. The Dambuster story begins with laughter and ends with silence. Laughter when Wallis proposed a bouncing bomb. Skeptical laughter when he rolled marbles across water tanks. Dismissive laughter from Air Ministry officials who thought he'd lost his mind. But the laughter stopped on the night of May 16–17, 1943. It stopped when the first upkeep weapon skipped across the Möhne reservoir, bounced over the torpedo nets and exploded against the dam wall. It stopped when the crack appeared in concrete the Germans had thought invulnerable. It stopped when 140 million cubic meters of water began pouring down the Ruhr Valley, destroying everything in its path. The Germans, who'd felt safe behind their massive dams, discovered that safety was an illusion. The British, who doubted Wallis's circus trick, watched the newsreel footage of breached dams and flooding valleys and understood they'd witnessed something extraordinary. And Barnes Wallis, the polite, methodical engineer who'd been mocked for his absurd idea, stood vindicated. His bomb had worked exactly as he'd calculated it would. The bouncing bomb didn't win the war. No single weapon or raid could do that. But it proved something perhaps more important, that innovation, properly applied, could overcome any obstacle. The Ruhr dams had been designed to be invulnerable. Massive concrete walls, torpedo nets, anti-aircraft defenses, geographic protection, every possible defensive measure. And they'd been defeated by a spinning cylinder that bounced across water. Years later, German engineers studied the upkeep weapon and calculated that the attack should have been impossible. The precision required, the training needed, the coordination demanded, all of it was beyond what seemed humanly achievable. But Gibson's crews had achieved it, because they'd trained until the impossible became routine, because Wallis had calculated every variable and refined his weapon until it worked perfectly, because Britain in 1943 needed something spectacular and extraordinary people delivered the impossible. The last word belongs to Air Chief Marshal Arthur Harris, the man who'd initially opposed the raid as a waste of resources. After the war, he revised his assessment. "I was wrong about the bouncing bomb. I thought precision special operations were a distraction from the main effort of strategic bombing. The Dambusters proved that sometimes 19 aircraft striking the right target achieve more than 1,000 aircraft bombing area targets. Wallis was right, Gibson was right, I was wrong, and I'm grateful that they proceeded despite my skepticism. Because that raid, that impossible, absurd, brilliant raid, proved that British innovation and courage could still change the course of war. On May 16, 1943, they'd laughed at Barnes Wallis and his bouncing bomb. By dawn on May 17, the laughter had died. The dams were breached, the floods had come, and the Ruhr Valley was drowning. The thunder of the breaches echoed across Germany, and in that thunder was a message the Germans couldn't ignore. Nowhere was safe, no defense was invulnerable, and British engineering genius could reach targets the Germans had thought impossible to attack. They'd laughed at the bouncing bomb, until it blew open the Ruhr.